Okay, anyway, a good welcome to everybody for today's session. All right. Yeah, for those who are joining us for the first time. Okay, so this is Mr. Augustine here, taking you all today through some heuristic solvings. Okay, I think I see a few new friends coming in. Is that right? Yeah, I think Arush, Aral, yeah, some names I'm seeing for the first time, but okay, so look forward to the next 1.5 hours with you all. Okay, without further ado, let me share the slides. Let me get it on first. Sorry, need to share screen. There you go. This is a share screen. Okay, there you go. Okay, so just a double quick check again. Is everybody able to see and all that? Okay, just let me know if there's any issues. Yeah, I think I see a few more friends coming in. All right, thanks, Giselle. I see your thumbs up. All right, I hope we are good to go. All right, so today's session, okay, we'll be looking at solving word problems involving repeated identity and problems involving number times value. Okay, so that's what we'll be looking at today. So two main types of problem solving questions. Okay, let's start with a pattern. How many of you are very familiar with such patterns? So how do we add this? We're starting from 1 plus 2 plus 3, all the way up to 88 and until 89. So what is the digit in the tens place of this total? So what do we need to do? Okay, see? All right, I see Dan's answer already. Just a very nice, simple digit. How about the rest? How do we find this? The question is asking for the digit in the tens place, not the total. Okay, for the answer, we can find the total if we want to as well. But what do we need to find here? Okay, I see Dan breaking down the steps. Giselle gave the answer as well. Okay. How the rest? Let me just go through the list to see if there's anybody who wants to say anything. Yeah. Yes? Anybody besides those who gave the answers? I see Liana's answer as well. I see Tanishka's answer. Yeah, they're all correct. So far, those who typed in the chat box are all correct. Anybody else would like to try? Oh, Arush, you got it right too. Great. Anybody else? Gordon, how about you? No? Regina? Ara, have you answered? Have you tried? Let me see. Jia Huan, is it? Okay. Yeah, so there's a particular pattern, all right? This is the numbers that are increasing, all right? Consecutive numbers. So when you add them, they become what you call a triangular sequence. So how do we add them up? There are quite a few ways to do it. So I saw Dan's explanation. So you're saying that you take the first and the last number, okay? You add them together and divide by 2. The rainbow method, you call it. Okay, fine. I also sometimes refer it to as the rainbow method. So you see what happens is you pull out the 1 and the standalone term 89. Okay? You see that there are actually a total of how many pairs? There are 44 pairs and 1 by itself. Okay. So how do we work them out? Each pair will be 88 plus 81, which is 89. Okay. So the tens place will be a 0 because when you work that out, the digit, as you can see, you multiply them together. Okay. So altogether there are 45. Okay. 45 of them, 45 pairs, that's worth 89. Okay, actually, to be precise, it's only 44 pairs. But because the last number, the 89, is by itself, that's why we have a total of 45 of them. So 45 times 89 or 89 times 45 will give you the answer. All right. So working that out, you get 4005, which is the digit in the tens place. Okay. 9 last number divided by 2. Okay, that's what Giselle says. Okay. Yeah, then is given the, okay, then is used the method known as the Gaussian formula or the Gaussian elimination method. Okay. So yeah, you have a few ways to call that. Okay, so this is the Gaussian. Some may just simply call it the Gaussian formula. You can just search for this. Okay. So how this works is, it was discovered by this mathematician. Or is he a mathematician? I'm also not sure, but he was the one who discovered this formula. Okay. So for consecutive series of numbers, you can actually just take the last number multiplied by the next number and divide by 2. Okay. Which is why you can see that the value is, you can say it's 45 times 89 or 89 times 45, which is what you see here. So this is another way of looking at it, right? You can pull out the pairs of numbers, okay, to get 45 times of 89 as well. So the tens place, as you can see, is a 0. All right, the digit is a 0. Okay, how many of you have seen this kind of patterns before already? I think those who have given me the answer, you all understood, right? What about those who are seeing this pattern for the first time? Yes. Okay, yeah, that's right, Giselle, you can do that. Yeah. Yeah, then you call it the rainbow method, or you can do the other way, which is the Gaussian formula. Yeah, Regina. Yes. Okay. Yeah, so this is a pattern. You can check this out. Okay, great. Let's move to the next one. Is that okay? Anybody taking down anything? If not, we move on. Oh, sorry, I saw a hand. Who is it? Dan, is it? Oh, you're writing something, is it? Okay, okay, sure. Yeah, actually, that is also my advice. You can actually take a screenshot if you want to. All right. Yeah, the screenshot, you can automatically save all these things in one go. So you do not need to actually copy. Okay, anybody else? Oh yeah, hi, I'm Rita. I just saw you just came in. Hi. Yeah. Okay, yeah, so we are just at this very first question only, and just continue. We can you can just continue with us from here. It's okay. Right. Okay, can we move on to the next one now? Okay. All right, let's have a quick check on the next one. Okay. All right, Giselle, yeah, I got to erase that, please. Thank you. Hey. Oh, I forgot that I'm using the, yeah, I should use the pen here. Okay, I forgot. Never mind. Next one. Okay, let's look at this one. Find the sum of the even numbers ranging from 1 to 42. Okay, so how do we find only the even numbers? Okay, because from 1 to 42, as you all know, there will be odd and even numbers, right? So 21 of them are odd and 21 of them are even. How do we only just get the even numbers? That's all, right? What do we need to do? Is there a trick that we can do? Okay, I see, let's see, I saw Dan's and Tanishka's answer. Okay. All right. Yeah, I also see Liana's answer. All right, great. Okay. Anybody else would like to try? Okay, I see Jia Huan's answer. Giselle. Okay, don't worry, Giselle. We can check it out in a moment. Okay, so let's look at the list of the even numbers as we go along. Right. So we have 2, 4, 6, 8, all the way up to 42, right? Because those are the Those are the even numbers. So how are we going to use them? So we pull out the standalone number first because, as you can see, all of them are actually 2, 4, 6, 8, 10, right? Excluding the 42 because 42 is by itself. Okay.
Then
Otherwise,
you just have to add them. You just have to add them.
Yes. Okay. Yeah, that's right. So we just need to add them. Okay. So we do the ones followed by the tens. So altogether, there are actually 10 pairs. Okay, because if we're only considering the even numbers, don't forget. All right. So although there are 20 pairs, but because we're only considering the even numbers, that's why there are only 10 pairs, half of them. Do you understand that? Okay, Jia Huan, oh, you put that as your answers. Okay, we'll check it out. Okay, see whether that's okay. So the sum of each pair, all right, will be 2 plus 40. Because as you can see, 2 plus 40 is 42. The next pair, just like the rainbow method that I think Dan was saying just now, okay, see 4 plus 38 again is 42. Right? So how many pairs of 42s are there? There are 10 pairs of 42. So that's why it's 420. But don't forget, with another standalone 42 by itself, okay, so it becomes 11. 42 times 11, which gives us 462. Okay, so those of you who wrote 462 is... So I think, Java, you just need to add another 42 to it. You get 462 as well. Okay. Yeah, so actually it's the same method you can use. All right. Okay, so we find the number of pairs. Okay, for pairs. And then once you find the number of pairs, okay, you can multiply them already. So this is the part. But because it is only even numbers, so you gotta be very, very careful. Okay, because we have to exclude the odd numbers, which is why we're only dealing with the even numbers. So there's only 10 pairs, in other words. Okay. Let's see. Is anybody else is saying anything? Standalone as in we separate it from the rest. Okay, because we're only taking those that complete the entire set from 2, 4, 6, 8, 10. So that's one set. And then the next 10 will be 12, 14, 16, 18, 20. That's the second set. All the way until 40. Which means to say 42 is alone by itself. There isn't a 44, 46, no more. It stops at 42. So we separate 42 from the rest. Okay. Any questions from anybody else? All right. Anybody needs some time or need to ask anything? Okay. Can we move on? Who needs time still? If not, I move on. Okay. Okay, so let's look at the next thing on repeated identity. Okay, so what is being repeated? What is the identity that's repeated that you're thinking? What you're expecting to see here when we say repeated identity? Yes, repetition, but what exactly is the thing that's being repeated? Yes.
Numbers.
That is from who? I didn't catch. Yeah, numbers. Oh, Gordon, yes, please, Gordon.
Numbers, yeah.
Okay. Eating the same numbers? Oh, that's Giselle saying. Oh, repeating the same numbers. Okay. Yeah, so when we say repeated identity, we mean to say that the same thing is used in a different part of the same question, which means to say that the same identity, we will do the making them the same. Okay, so let's find that out now. Oh, sorry, did I press too fast? Oh no, okay. Oh, I missed one part. Okay.